Hello everyone, so today we are going to do Leetcode Daily Challenge Course Schedule 3. So basically in this question, we are given with duration and last day, right? So the thing would be that we are required to complete all the courses continuously for duration I days which is being given to us, and in each of these durations are being given lesser than the last day, right? Means in each of them duration is less than whatsoever would be the last day, or it could be even equal to that day. But the thing is that we need to complete all this continuously. So how we can complete them is by, like, if we choose this first course, then we add up to this particular course, right? So if we choose this first course, then it could be completed, right? Because last day is 200. But then we add 200, means we now go to this particular course and last day is 1300. So now it aggregate would be 300, which is less than 1300, right? So that's why we can take this course also. Then we go to this 1000 course and its last day is 1250, right? So if we add 1000, right, which becomes equals to 1300, right, which is not less than 1250, right? So here we need to do something, that which one we are required to take. So that would be the thing here, because here the courses could overlap, right? So that's why we are required to take courses in such a manner that these things don't take place. Means the way here it is being written, right, that first course could be taken, right, and then second, third course could be taken. Second, third, it costs 1000 days, right? Now the first example which I gave you, the thing was that there we got stuck in these last days, right? So at that moment of time we were not able to get that how much courses we can take, and because at that moment we were only given with 2 courses only which could be taken, but in actual the answer is 3, right? So now comes the part that there is some more requirement for this particular question. So if we sort all these, and sorting that need to be done in increasing order of last day, right? So the new vector would become something like this: 100, 200, right? And then it would be 1000, 1250, right? Now we can take it easily. Earlier because we were having issue, right? So now we can easily take up the courses in this manner. Means first 100, which is already less than 200, right? So we can take this. Then 1000 we could take, which one will be equals to 1100, which is less than 1250. So we can take this. Then if we add up 1000 plus 200, that would become 1200, right? This is already less than 1300, so we can take this course also. But if we add up 2000 for the same, right, then it becomes 3200, which is we are doing something wrong, I guess, because okay, here it is one, I missed that. Here it was like this, right? So it becomes equals to 3300, which is not less than 3200, right? So that's why we can only take 3 courses, that is these 3 courses. So that's why now, while going through these conditions only, we just got one point, that we are required to sort these, right? And after sorting only we can get our solution. Now comes the part that okay, sorting is done. We'll sort our courses already, but how we will be able to compare that fact that if that particular duration is smaller or greater, if we want to optimize our solution more? Because there could be a case that 2 courses are being taken of whatsoever duration would be, but if two courses are taken in such a manner that last time which is there, basically they both of them agree for the last time, right? But if we take one of them, so then we would be able, if we take either of them, so we would be able to get possibility of adding two more, rather than if we take the other one, because of which we were just only able to add only one course to our curriculum, right? So which one would be more optimized? Obviously the first one, in which we are able to do 4 courses rather than the one in which we are doing 3 courses. Let me check if there is that example or not. Actually there is not. So the thing which I was saying was that if here it is given as 100, right? So 1000. So if there was some case like 2000 is there. If there was some case like 1500, right? And let us take same this one only, right? So not same, let us take like this. So till now as it was sorted, so it would have been something like this: 100, then 1000, then 200 being added, so it would be something like 1300, right? So on the other cases we take, then it would be 100, and then because it is 55, so it would come later, right? So yeah, it would come later, and here we'll get this one, and then there is 1500, right? So it would be 2500, right? That would be the 2600, right? And this 2600 would be, so this would be eradicated. Really not getting the example, but the thing is that if we get some case which is like means, okay, let us if we get some particular case which is something like that, it is not able to go ahead with this particular last time, right? And there are 2 more cases which could be added if it is able to go ahead with this last time also, and there are 2 cases which are required to be added. If we choose this one, then we are able to add both of the cases. But if we don't choose this one, right, then there is some other one also, and if we choose that one, right, then we are not able to add these cases. So there would be this one only. So in that scenario, we are required to also keep a check that if the durations are basically, if the duration, whosoever duration would be less, then in that particular scenario, we are required to have a particular data structure which could keep at the top that whatsoever duration is basically shorter one, so we could easily take that. So that's why this particular question becomes the question of heap. So let me walk you through the code that how we are required to do. So in C++, actually the heap is by default as max heap, right? So in that scenario only, we are required to go ahead like this. First we will start with a Boolean comparator so that we could sort it easily. Why we are required to have a custom comparator? Because if we would have been sorting this, then it would have been surely sorting in this manner that whatsoever is at first, basically the durations which are at the first, right? So it would have been sorting these in increasing order, and then it would have checked for the second one, which if the first ones are equal, then only it would have been checking for the second one, that out of those which one is lesser. But now we are not required with this one. Our requirement is that we are required to sort on the basis of last state, and that also in increasing order. So that's why we are taking in this manner. So our Boolean comparator would be something like this. Now here the size has been taken, time has been taken, this time has been taken so that we could have the aggregate that whatsoever time the previous course has taken, basically the duration, adding that, and then the present duration we could add up and then check that is it still in the last time range or not. That's why we have taken this. And now taking this as it is, because we are provided with max heap inbuilt by C++, that's why we are not required to have any comparator for the same. Now sorting it as per our condition. Now next thing, this is our main logic which is required here. So the thing would be that we are required, because this is vector of vector, right? So we will take one particular vector from our courses vector, then we will check that is the time and the course, basically the duration. If the duration and the previous duration which the previous course has taken, if adding both of them is still less than or equal to the present last time, right, then only we will add that duration to our time and we will push that to our queue, basically our priority queue. Else, if this is not the case, if it becomes greater, right, so in that scenario we can't push this particular to the queue, right? So what we means, in that scenario we could not directly push this into the queue, but we are required to basically pop out the maximum which was there with the lesser duration, because it is a max heap, right? So it will sort everything as per the first which is there, right? Whichever is there. So it will sort according to that and it will directly get it out, help us to get that out from that particular queue. So we'll check that if it is empty or not, if it is not empty, and if the top which is there, if it is greater the duration of a present course, right? Basically current course is actually of less duration and can be taken, because our max heap would be having the maximum duration at the top, so we can compare them and we can directly get them out. And then duration is less, right? So it becomes more realistic that we can take much more courses, right? So that's why that was the point I was trying to explain at that particular time, but I'm unable to get some test case for the same, because if I got, then it would have been easy to explain. So now here the thing is that if int x equals to q.top, why we are taking this, so that we could directly decrease from our time and then we'll pop it out, right? Because we'll pop it out and then we will push at this particular course to the queue and then we'll increase that particular course timing here, because it was obvious that we are required when we are adding in the queue, then we are required to add that particular time also to our queue. And at the end, whatsoever courses we are would be in our queue, basically those many courses we can take. So that's why we are required to return the size of the queue. So basically for this, our time complexity would be simply order of NlogN, because at max we could take all the courses also. So that's why it's order of NlogN. And the space complexity would be also order of n, because at max we can take all the courses, so all those courses which are stored in the queue. So that's why this is all for this particular question. If you have any doubt, you could comment it down. And please do like and subscribe and share my channel if you really like the explanation. So thank you.